Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 3.9 entitled Percents. And today we're going to write a percent as a decimal and write a decimal as a percent. So we're going to convert back and forth between the two. And then we're also going to find the percent of a given number. And that was something that we did in our review at the beginning of the year. So to define a percent, it's actually a ratio that compares a number to 100. So this is why we're doing this section, since we just got done talking about ratios and rates in the previous lesson. A percent is a specific ratio, and it always compares a number to 100. That's what percent means. It means out of 100. And you can write a percent as a fraction, as a decimal, or as a number followed by the percent symbol. So we're going to look at example 1 here, and we're going to write each percent as a fraction and as a decimal. So since a percent means that it's a ratio out of 100, the easiest way to write it as a fraction is to put that number that you're given over 100. So for part A, I'm going to take 42%, and I'm going to write it as 42 out of 100, and then reduce it. And to reduce it, I can divide by 2, and I'll get 21 out of 50. And then to write it as a decimal, you would just divide. You'd have to divide 21 by 50, or actually divide 42 by 100. And that will give you 0.42. And a good way to write it as a decimal is to think of it like a fraction. You could think 42 hundredths is how you would read that fraction. So that's how we would write it as a decimal too. 0.42 would be 42 hundredths, since the 2 is in the hundredths place. The other way is to use what you know about converting a a decimal to a percent and a percent to a decimal. You can just take the decimal that's behind the 2 in the 42 and move it to the left 2 places, and that converts your percent into a decimal. So for part B, we have 300%, so I would just put 300 over 100 to make it a fraction. Remember, it's always going to be out of 100. So when you reduce that, that's just going to be 3. And then if you write this as a decimal, you could move the decimal behind the 0 2 places. So you'd have 3.00, which is also just 3. So for this one, the fraction and the decimal end up being the same because they're whole numbers. Okay, for part C, this one's a little trickier because they give you a decimal in the percent. So that's not hard to write it as a decimal. We can just move that over 2 places. So we would have 0.109. That's our decimal. Okay, but the fraction part is the trickier part. We're still going to put 10.9 over 100. And then we can't really have a decimal in a fraction. That's not mathematically correct. So I'm going to scooch this decimal to the end of the number. But what I do to the numerator, I have to do to the denominator. So I got to scooch the decimal in the 100 as well. So now I have 109 for my numerator, and then I have 1,000 for my denominator. So I have to fill in that place that I scooted the decimal over. I got to fill him in with a 0 for a placeholder. And then if I can reduce 109 over 1,000, I can go ahead and do that. I actually can't. I can't reduce it any more than that. And there's a little note here. When you write a percent as a fraction, make sure that there are no decimals, and then reduce it. So that's what we just did. When you write part C as a fraction, make sure there's no decimals left in it, and then reduce it. And then to change a percent to a decimal, it's probably easiest just to move that decimal point 2 spaces to the left. Okay, now for these next examples, there's basically 3 types of percent problems that we're going to be doing. And your book talks about them in this format. They give you a general format for the percent problems. So I'm going to show it to you and explain it to you so that way if you're looking in your book and you're seeing this, you kind of know what it means. But really, I think this is a little more confusing than what the problems need to be. Okay? Um, but this A that they give you, this is just a number. The P over 100, that's going to be your percent. And then the B, that is going to be your original amount. So no matter what the wording is for the problem, you can substitute in the given value for either A or P or B into this formula, and you can solve it for the other variable. And like I said, there are three basic types. Okay, you're going to see a problem that says, what is P% of B? So you would actually be solving for A there. So you'd have P% of B, so you'd be multiplying, and you would be solving for A there. You'd be finding that amount, that number. For this other one, you would have A is P% of what? So A is P% of what? And that would be the B that you would be solving for there. And then the last one is A is what percent of B? So this one you'll be solving for P. So wherever it says the what is where you're going to be substituting the variable. The other values you should know. You'll have a value for A or for B or for P, but wherever it says what, that's what we're going to be finding. Okay, so regardless of how you want to think of this, if you want to think of it as the book formula or how I'm going to demonstrate it, I can do it both ways, as a decimal and as a fraction. You're going to get the same answer with whichever method you use. Okay, and we're going to be using some of our translation skills. We're going to be changing a percent into a decimal. Okay, we're going to be using our solving an equation skills. So for example 2, these all say in the directions to solve for A. It's not necessarily going to say that in your homework or in your worksheets or your quiz and test, but it's just, for now, it's just a hint to tell you that we're going to be finding that number that stands for A in that problem. Okay? So we have, what is 15% of 100 meters? So here's our what. That's what we're going to be finding. We're going to change the percent to a decimal. And then we're basically just going to translate it and substitute in what we know and what we don't. So what is going to be my variable? If you want to call it A, you can call it A. If you want to call it X, you can call it X. Is means equals 15%. Now you can change it to a decimal, so you'd have 0.15, or you could do it as a fraction, and I can do that down here. You could do 15 over 100, 15%. Remember, percent means out of 100. Of means times, and the other value we know is 100. So again, you'd be doing that down here too. Now, I like the problem where you change it to a decimal, because then you can just plug it into your calculator and multiply. So 0.15 times 100, that gets you 15. And our units here, we were dealing with 100 meters. We're finding 15% of 100 meters. So we have 15 meters. And same thing down here, if you multiply a fraction times a fraction. Here it's nice because the hundreds cancel. So this is really good visualization for how you get that 15 for a final answer. So if you want to write the problem as a decimal or as a fraction, doesn't matter. If you want to call the variable A, since we're solving for that amount, or if you want to call it X, doesn't matter. Okay, so part B is same type. We're still finding that number. They've just worded the question in a slightly different order. So when we write our equation, our variables might move from one side of the equation to the other. So it says 200% of 5 is what number? So there again, what number? That's where our variable is going to be. So the 200%, I can change that to a decimal. So I can just have the 2 or the 2.00 of is times, 5 is 5, is equals, and again, the what number, that's our variable, either the a or x, n, whatever you want to call it. Okay, so now I just need to multiply. 2 times 5, that's 10. So 10 is 200% of 5. And if you wanted to do this as a fraction, you could do 200 over 100, because percent, 200% means out of 100, times 5 equals a. And then when you multiply, you'd end up getting 1,000 over 100, so that would reduce to 10. Okay, you do not have to do the equation both ways. I'm just showing you two methods. If you prefer to do it as a decimal, or if you prefer to do the percent as a fraction, it doesn't matter. I'm just showing you that either way you think of it, you will get the problem solved and you can work through it and get the correct answer. So you pick a method that you like and you use it every time. Okay, example 3 now, we're going to be solving for b in that equation that the book gave us. So this is the original amount now. Okay, it's not our final amount where we're finding the percent. They're going to tell us the percent and we're going to find the number that they started with. But again, the best way to approach these isn't so much to think of it like a formula, it's just to kind of translate the equation as you read the question. So we have 12 is 60% of what number? So there again, there's that what number. That's where our variable is going to go. So 12 is 60%. I'm going to switch that to a decimal, so 0.60. Of is times what number? You can call it b, you could call it x, n, whatever. So now this one is set up a little bit differently. We're not just going to do straight multiplication here. Now we have to use our equation solving methods. I'm trying to solve this for b. That's what I'm trying to find. So it's being multiplied by 0.6. So that's what I have to divide by. So I have to divide both sides by the 0.60. And when I do that, I'll end up getting 20. And again, you could do this as a fraction. I'll write that in a different color. You could do 12 equals 60 out of 100 times b. And when you're dealing with that fraction, remember we don't divide by a fraction, so you'd have to multiply by the reciprocal. So you'd have to multiply by 100 over 60. So sometimes I think the fractions can get a little more intimidating. But when you multiply across and you divide, you still end up getting the same answer. You'll still get 20. Okay? So you figure out how you want to solve the problem, which method you like, and you do it your way. Okay, same thing for part B. We're still going to be finding that original number that we started with. So the equation is just, or the problem is just worded a little bit different this time. The equation might be set up a little bit different, but we're still going to use our same skills to solve it. So we have 2% of what number, that's where my variable goes, is $20. So 2%, I'm going to make that a decimal. So I need a placeholder now. I'm going to have 0.02 of is times what number is $20. And again, I'm trying to solve for b. So I have to undo this multiplication. So I have to divide by 0.02. So then b will end up equaling 1,000. And actually, it'd probably be $1,000 since we're finding 2% of 1,000 would be 20. And that's a good way to check your work too. Just reread the question and put that what back into the spot. Put your answer back into the spot where the what was. So we'd have 2% of 1,000 is 20. And you could double check that. You could take 0.02 times 1,000 and make sure you got 20. And again, the other way to do this problem would be to do it like a fraction. So you'd have 2 out of 100 times b equals 20. And then we'd have to multiply by the reciprocal, so that'd be 100 over 2. So you could think of that as like 50. 100 over 2 is 50. Okay. So again, over here, everything cancels, so b equals 1,000. Now our last one's for example 4. We're going to be finding the percent. And these I'm going to put a big star next to because these are the ones where you kind of have to do an extra little step at the end. You have to make sure that you write your answer as a percent. And this is the step that students forget over and over and over. But here for part A, we have 20 is what percent of 8? So I'm trying to get an answer that is a percent. When we get our answer, it might be a whole number, it might be a decimal, but we have to change it from that form into a percent. So we're going to have to move the decimal in our answer 2 places to the right. So that's what students often forget. They work through the equation, they get an answer, and then they forget to write it as a percent. So let's translate this one. We'll have 20 is means equals what percent, I'll put p, of is times 8. So now I'm going to solve this for p, so I'm going to divide both sides by 8. So I will have p equals 20 divided by 8 is going to be 2.5. And this is where students stop. They get an answer for p, they circle it, and they move on. But remember, it says what percent. So I have to do this extra step where I take that decimal and I move it 2 places to the right. So my final answer is 250%. So you have to do your very best to remember that when it says what percent, you make sure you rewrite your answer as a percent. And again, you could do this as a fraction. You could do this problem as 20 is what percent? So you'd have to do p out of 100 times 8. So again, this one's kind of nice when you do it this way because it helps you remember to move that decimal over. Okay, so we have to, like we did, divide by the 8 on both sides. We have to undo that multiplying by 8. So I'm going to divide by 8 and divide by 8. So I get the 2.5. But then I have p out of 100. So then I have to do that step where I multiply by 100 on both sides, and that's where I get my 250. So if you're setting these problems up as a fraction, you're going to have less chance of forgetting to do that extra little step at the end. Okay, now part B, same type of problem where it says what percent. It's just the way the equation is going to be set up might be slightly different from part A. So we have $240 is what percent of 50? Well, it's not very different from part A. Variables even on the same side. Okay? But either way, no matter what side the variable's on, we have to divide by the 50. We have to get the p by itself. So 240 divided by 50, that's going to be 4.8. And then again, I have to change that into a percent. Right now it's just a number. I need it as a percent. So we get 480%. Now it's just a coincidence that for both of these examples, we ended up moving the decimal and we had that 0 for a placeholder. Okay, so we end up with 250 or 480. That's just a coincidence. Your numbers aren't always going to be in the hundreds like that. And again, if you wanted to do this as a fraction, you would have 240 equals p out of 100 times 50. and then you'd have to divide by the 50, like we did. So you divide by the 50, and you still get the 4.8 equals p over 100, and then you'd have to multiply both sides by 100. So that's where you get the 480. And technically, when you're doing that problem, you could also think of this part, the p over 100 times 50. You could think of that as multiplying two fractions. And you could say 50 goes into 100 two times. So then you'd have, what was it, 240 equals p over 2. And then you would just have to divide by 2 on both sides. And then 240 times 2 gets you the 480. So there's a couple different ways to think through and work through that setup as well. Okay, last couple examples here. We have some word problems. Example 5 says you are shopping for a new pair of boots. And you go to Bubba's Boot Barn because they have a pair that you like, but they're $90. Now, luckily, when you go to the store, they're 30% off. And you have a 15% off coupon. And the store lets you use both. So you can use the coupons on the sale items. So how much will you actually end up paying for these boots? Now, a lot of times when students do this, they take the 30 plus the 15, they add them together, and they take 45% of 90. And that is completely and totally incorrect. That is not how you calculate a percent. Percents you have to do one at a time. So originally you had the $90 pair of boots, but they were 30% off. So we're going to find how much that 30% is. So we're going to do 30% or 0.30, that's a decimal, 0.30 times 90. 30% of 90. And that is $27. So just by walking into the store and seeing that those boots are 30% off, you're going to save $27. So 90 minus 27 now is 63. That's how much, if you went up to the cash register and bought those boots, you'd actually pay 63 bucks for them. But you have a coupon. You have a 15% coupon. So we're going to find that 15% of the 63. And that's going to be $9.45. So that's how much you'll save with your coupon. So now the cash register, the store, would take the $63, which is the sale price. They'd subtract that extra 15% that you're saving, and then you would finally pay $53.55 for those boots. Now that's without tax. There's nothing in the problem about tax being added or anything like that. So we're just going to assume you're finding your basic retail price here. But this is a really important problem because you have to understand that percents are done one at a time. You can't take the 30% and the 15% and add them together and get 45%. Okay? The store calculates the 30% off to get the new price. And then your coupon is an additional 15% off that new price. It's not 15% off the original price and 30% off the original price. So the percents are done one at a time. Okay, last example, example 6. According to the following table, what percent of people exercised 2 to 3 hours each week? And then we have a second part to this. How many people exercised 8 to 10 hours per week? So here we're going to take a look at our table. They tell us the number of hours that we have each category here for how many hours people work out each week. And then how many people are in those categories. Now if I'm trying to find a percent, what percent? Okay, now percent is usually out of 100, but in our case here, it needs to be out of the total number of people. So I have to add up this column and I have to get my total. And if I add those up, I'm going to get 105. So there are 105 people that they surveyed for this table of information. And this is really how you find a percent for most stuff. A good example for you guys might be a test score. Tests might not always be out of 100 points. Sometimes a test might be out of 97 or 72 or 63 points. Okay, so you have your total that you got correct out of the total points. That will also get you a percent. It'll get you a decimal that you can change into a percent. So that's really what we're going to be doing here. So to find the number of people who worked out 2 to 3 hours per week, that's right here, there were 49 people. So 49 people work out 2 to 3 hours a week out of the 105 people that they surveyed. And if you divide those on your calculator, you're going to get 0.467 if you round. And so that's your decimal, and we need to make it a percent. So I'm going to move that decimal over 2 places. So it would be 46.7%. So almost 47% of the people that they interviewed work out 2 to 3 hours a week. And you can see that's the largest number of people in the table. So that's going to be the largest percent. So 47, that's a big number. That's a fairly substantial amount. And then they also want us to find out how many people worked out 8 to 10 hours a week. So 8 to 10 hours, that's way down here at the bottom. There's only 5 people who work out that much out of the people who were surveyed. So we'll have 5 out of our total. And when we divide, we get 0.047. So to make that decimal into a percent, I'm going to move the decimal 2 places to the right, and I get 4.7%. And that should make sense. There were only 5 people who were working out. So that's a small number. That's the smallest number in the chart. Okay? So that makes sense that we get a really small answer, about 5%. So make sure when you're doing these types of problems, when it says to find the percent for this type of a situation isn't out of 100, it's out of the total number of people. So here's your homework problems where you can practice these skills. And if you have any questions about percents, come on in and see me before school.